I'm joined here with Sean. This is one of the workers with Vortex 2 NSSL, and I would like for Sean to briefly explain a little bit of what he does. Sean?
So what we have here is one of our NSSL mobile mesonettes, and we had about 7 of these used in the Vortex 2 field campaign that was just completed this past summer. And basically what these guys do is these guys run around underneath severe weather and any other weather if you really wanted to use it for that. And the idea is to collect mobile surface observations. If you have a stationary network, that's fine, but inevitably the storm misses your network. If you put it on top of a car and drive it around, you can actually get under the storm and get as many observations where you want the observation, so we can get a much more detailed resolution of what's going on at the surface of a severe storm than you can with the stationary network. So these guys run around, they have temperature sensors, they've got relative humidity sensors, wind speed, wind direction, we've got a GPS sensor that gives us the vehicle heading and vehicle speed. We've even got a solar radiation sensor on there that tells us how high the solar radiation values are. And all of this stuff goes into a logger box that's located on the top of the instrument rack, and then it comes down into the computer system that we have inside the car. And all this information is available not only to the people that are in the car that are driving the vehicle, but we also stream it live back to a server in the weather center so that we can archive this data and look at it later and hopefully do some analysis and figure out what's going on underneath these severe weather. So there's a lot of complicated design that goes into the design of this vehicle. We've got to put all the instruments on top of the car without damaging the vehicle. We have to put all the instruments inside the car, the computer, the inverter, the battery, the fuses. All of that has to be done without actually hurting any of the integrity of the car. We have to give these vehicles back at some point, so we can't drill holes and everything. So the design process is pretty complex for this kind of stuff. You've got to spend several hours trying to figure out where you want to run everything, figure out how to put it all in there, and then figure out how to get it all back out later when the leasing company comes back and wants their vehicle back. Obviously, hail damage is a little bit of a problem. Our hood has quite a few dents on it. The side mirrors take quite a beating, but it's all in the name of science, and we can do it anytime.
One other question for you is, what would you tell people that if they wanted to pursue something like this, what would be some of the advice you'd give them as pursuing a degree, or what helped you get to it that you would give others to get this point?
A degree in meteorology, just like any other field, isn't an easy task. You know, getting a degree in anything takes a lot of dedication and a lot of hard work. Obviously, you know, a degree in meteorology, you're going to need a lot of science and a lot of math background, but if you're really passionate about the weather, you'll find a way to make it work. Just keep trying, keep practicing, you know, do your math, do your science in the lower education levels like high school and middle school and grade school. And when you get into college, if you really want to do it, don't give up. If you don't succeed in a class, take it again, try again, just keep trying and you'll eventually get there.